there are a bunch of different properties of a programming language that determine what it is to be a program in that language. We've looked at a bunch of properties. So one of the properties of Scheme is it has first-class procedures. Another property of Scheme is, well, it's applicative order. And another property of Scheme is it does have variables, and so on. Okay? Lots of different things that make Scheme Scheme. And every one of those things manifests itself in the interpreter. So we can look at the interpreter and ask questions like, how would I change this interpreter if I wanted, just like Scheme, only normal order? Right? And the answer is, you would not call map in here, but just use could or exp as the second argument to apply. And then we would be giving apply actual argument expressions rather than actual argument values. Okay? Which is what normal order means. Actually, I'm saying this with my fingers crossed, because in a real language like Scheme, it's a little bit more complicated how normal order works, and we are going to get to that. But basically, this is applicative versus normal order right here. Okay, so we call apply with exactly two arguments. The first argument is the function that we want to apply. Apply is, a fancy name for call a function. And the second argument to apply is a list of argument values. Even if there's only one argument or no arguments, it's always a list. And that's so that it has a uniform definition. So function, arguments. And in the definition of calc apply down here, you see that it takes function and arguments as its arguments. Okay. Here's the place where the calculator program diverges from what Scheme does. It's not just a simplification, it's actually a difference. And that is, in actual Scheme interpreter, it's the procedure itself, because procedures in Scheme are first class. So that function argument would be the procedure that adds numbers, or the procedure that subtracts numbers, or the procedure, et cetera. In this calculator, we don't have procedures as first-class values, which is a big simplification. And so instead, the first argument to apply is the symbol that names the function we want to use. So it's the plus sign or the minus sign, et cetera. It's a little bit like the distinction between applicative and normal order, except that instead of being about the arguments, it's about the operator, the function that we're calling. And we give the name of the function rather than the function itself, because there's no way to represent that in our calculator. We're going to look at a still somewhat simplified Scheme interpreter that does have first-class procedures, and you'll see how that works differently. So this calc eval is actually a little more complicated than the real one, because it has a cond with 5 cases. Is this plus? Is this minus? Is this times? Is this divide? Else error. Okay? So that means if I say something like, square root of 4, I get bad operator, square root. Okay? And that call to error, by the way, I guess we haven't explicitly talked about this. Error is a Scheme primitive that prints an error message and gets you back to the Scheme read eval print loop. Because STK is an interpreter just like this. STK has a REPL and an eval and an apply. Just the same as this, except for Scheme instead of for the calculator language. So we really are looking at something pretty real here, except for this business about 4 different con clauses for 4 different operators. So plus and times are easy. We treat all the arguments the same way. Minus and divide is a little more complicated. we can't call them with no arguments. If we call them with one argument, then we return either the additive inverse or the multiplicative inverse of that one number. So either minus car of args. So if there's only one argument, args is still a list, and the one argument is car args. So here I'm taking the additive inverse, minus car args, and here I'm taking the multiplicative inverse. Divide, real scheme divide does the same thing. So this is like saying 1 divided by car args. Okay? Otherwise, what scheme does, scheme actually allows multiple arguments for minus and slash, even though it's kind of silly. And it treats the first one differently from all the other ones, basically. So it takes the first argument minus the second argument, that result minus the third argument, that result minus the fourth argument. So the way I represented that here is take everything except the first argument and add them all up, and then subtract that from the first argument. Probably would have worked to let scheme handle this, but I'm making explicit what the semantics, the meaning of minus and slash actually are for these funny cases where there's multiple arguments, more than 2. 2 arguments is straightforward, but this handles 2 arguments also. Okay? Questions? Yes? What's the point of the 1 or the 0 in the accumulate procedure? Accumulate takes an accumulator function, like times in this example, and a base case value. So what's the starting point for the accumulation? So it starts with, in this case, 1, and then it multiplies that by the first argument, and multiplies that by the second argument, and so on. Does that answer the question? Yeah.